Which graph best represents the relationship between kinetic energy and velocity of an object accelerating in a straight line? So it's accelerating. This object is changing its velocity. Let's make an assumption that the velocity is going up. So if we look at the graph on the y, or any of the graphs, kinetic energy is on the y-axis and velocity is on the x-axis. If we go in this direction along the x-axis, velocity is increasing. So in this graph, if velocity is increasing, and if you go this way, kinetic energy is increasing. We can use the equation as a guide. And we'll write the formula for kinetic energy before we get started. I'll just write it up here on the top where we have some space. Ke is 1/2 mv squared. And from this, Ke is proportional to v squared. That means if I were to travel with a velocity of 1, I'd have a kinetic energy of 1. So let's just do that here. 1, 1. If I go twice as fast, I'd get 4 times the kinetic energy. 3 times as fast would give me 9 times the Ke. 4 times as fast would give me 16. So if I go twice as fast, I get 4 times the amount, 3, 9, and so on. This gets rid of any kind of linear relationship. First of all, hey, this one's impossible because as you increase velocity, kinetic energy does not stay the same. Goodbye. And we made an assumption that you're going to speed up, so when velocity increases, kinetic energy does not go down. That's impossible. So it leaves us with 2 possible graphs, graph B and graph D. So this one says when velocity goes up, Ke goes up. That seems possible. And this one, when V goes up, Ke goes up. But if you look at our data set, as velocity goes 1, 2, 3, 4, Ke does not go 1, 2, 3, 4, a straight line relationship. This is a nonlinear relationship. So D is the correct answer. Or another way to think about it, kinetic energy is proportional to the square of the velocity. Y is proportional to x squared. And we know x squared is parabola. D is the answer.